All right, we are in the last unit, or the last lesson of this unit rather, quadratic models, any situation that can be modeled with a quadratic function. This is lesson 10.6, so let's get started. We're going to work through this with an example. I think that's the best way to do this. So let's imagine that a man has 480 feet of fence and he wants to make a pen, like a kind of a holding area for his sheep. He only needs to fence 3 sides because he's already got a barn to serve as the 4th side of that area that he wants to fence in. So what would be the area if the width is 50 feet? So if I already know the width, let's figure this out. He wants to, another question would be if he wants to maximize the area for his pen, what should the dimensions be? So those are going to be treated as 2 separate questions. All right, so here's the solution. We're going to label the width with X, and then since he has only 480 feet of fence, then I take the 480 feet total and I subtract both of those X's that I've already labeled, so the length must be 480 minus those 2 X's. Alright, so I've got the length and the width of my rectangle, so I can figure out the area by multiplying them together. The area is going to be calculated as X, the width, times 480 minus 2X, which is the length. And if I actually use distributive property on that, I get that the area can also be calculated as y equals negative 2x squared plus 480x. Okay, so let's answer that first question first. If the width is supposed to be 50 feet, then I'm going to set x equal to 50 in that quadratic function that I just mentioned. So I'll replace every x with 50 and I will get y equals negative 2 times 50 squared plus 480 times 50. And that gets me an area of 19,000 feet. Okay, so to find the maximum though, that might not be the maximum, so I'm going to graph the function and look for the maximum area, and that's going to be at the highest point on the graph. That's actually going to be at the vertex. So where is that vertex? Well, if I solve that equation, it was in standard form. If I try and figure out where the x-coordinate of the vertex is, I'll use the formula x equals negative b over 2a. Which is going to be negative 480 over negative 4. That's going to be 120. So I know that the width of the maximum area is going to be 120. Now what's the length? I'm going to take that width and I'm going to double it, because there are 2 widths that are 120, and subtract that from the 480 worth of fencing that I had to start with. And that leaves me with 240 feet of fencing for the length that I have to do. Okay, so the dimensions of that fenced-in area are going to be 120 feet by 240 feet. So that's kind of a way that you can take problems that are modeled with quadratic functions and you can solve them by graphing or by algebraic solution methods. If you have any questions about any of this, please let me know, and I will see you tomorrow.